integrate a squared minus x squared dx. Now to integrate this integral or this function, uh, you have to do a trig substitution. Okay, so this is an example of trig substitution. So here what I'm going to do is, my intention is to get a 1 here. Now to get a 1, I'm dividing a squared by a squared and x squared by a squared. So if you factor out uh, 1 over a squared, when it comes outside the square root, it will be 1 over a. And to cancel that 1 over a, I have put an a squared here, a here, so that it cancels. So basically this step and this step are the same. Or in other words, you have multiplied inside this inside this radical or square root, you multiplied by 1 over a, and you have kept an a to cancel that 1 over a. I hope you understand this step. So basically, I'll repeat, when you factor out 1 over a squared from inside the radical, you'll have 1 over a here, and that 1 over a has this a to be cancelled with. So this is the first step. I hope you understand why I need a 1 here. Okay, I'll come to that later. So the next step would look like this. That is a times square root of, this is not a decimal, so this is 1 minus x squared over a. Now, I hope you know the trig identity of sine squared x plus cos squared x is equal to 1, which implies 1 sine squared x sine squared x is 1 minus cos squared x, or cos squared x is 1 minus sine squared x. So that's the reason I want a 1 here. So I'm going to do a trig substitution. I'm going to take x over a as sine theta. Okay, so this is a trig substitution. So x over a is sine theta, which implies x is equal to a sine theta, cross multiply or multiplying both sides with a. Now integrating with respect to theta, differentiating both sides with respect to theta, we get differentiation of sine theta is cos theta. So dx by d theta is a cos theta. Okay, now this implies dx is equal to a cos theta d theta. Okay, so what happens now? So in place of dx, I'm going to put a cos theta d theta, and in place of this I will put x squared. So this implies x squared over a squared is nothing but sine squared theta. I've done all the steps so that I don't waste time in writing the steps down. So this becomes a times 1 minus sine squared theta times a cos theta d theta. Okay, so this is nothing but a times 1 minus sine squared is cos squared. Okay, and square root of cos squared is cos. So this is pretty simple. So a times cos theta times a cos theta d theta. So here now you got, this is a times a is a squared cos squared theta d theta. Now to integrate this, you can do in different ways. I'm using the double angle formula, so this is the double angle formula. Cos 2 theta is 2 cos squared minus 1. This is one of the three formulas of cos 2 theta. So if you make cos squared theta the subject, that is nothing but 1 plus cos 2 theta over 2. Okay, and that is same as cos squared is half. You can factor out a half, 1 plus cos 2 theta. So in place of cos squared, I have put a half times 1 plus cos 2 theta d theta. Okay, so now you can factor out the 2 or half, so that's a squared over 2. So this is called a power reduction formula. And now integrating, so integration of 1 with respect to theta is theta, plus integration of cos 2 theta is sine 2 theta over 2 plus c, which is the constant of integration. Okay, we're almost there. So this becomes now I'm multiplying, so you are multiplying, so this is, you're multiplying this 2 theta over 2, which is 2 theta plus sine 2 theta over 2. Okay, so this becomes, now, okay, so this is the form. Now we'll come back to the substitution. If this is what we started, or this was a trig substitution, that x over a is sine theta, so theta is sine inverse of x over a. So that's it, result 1. Excuse me, if you square both sides, sine squared theta is x squared over a squared, which is nothing but 1 minus cos squared over, is equal to x squared over a squared. Okay. The next step is, if you make cos squared the subject, cos squared is 1 minus x squared over a squared, where this is nothing but the multiplying both by a squared. So if you multiply this by a squared, you have to multiply this with a squared, or cross multiplying, so a squared minus x squared over a squared. So cos theta is 1 over a times square root of a squared minus x squared. This is result 2. Okay, so let me remove the veil. So this becomes, so this is actually, I have copied and pasted from here. So this and this are the same. So a squared over 2. So this is this form. So now I'm simply substituting. So I know sine theta is x over a and cos theta is 1 over a square root of a squared minus x squared. So this becomes, so this has come from here. So this becomes, if you want to do one step here more, this is a squared over 4 times 2 theta plus sine 2 theta plus c. So this 4 has come from 2 times 2 is 4. So that's what the same thing is, and now substituted. So theta is sine inverse of x over a plus 2 times sine theta is x over a times cos theta is 1 over a times square root of a squared minus x squared plus c. Okay, so now this is simple simplification. So this is 2, so this becomes 2x over a squared times square root of this. Okay, and then you are expanding with a squared, so this is 2a squared over 4 times sine squared x over a plus 2x or 2a squared x over 4a squared. So this becomes half. So this a squared and this a squared gets cancelled. This is again half. So finally, this is the final result. So integration of, so we can say this is integration of square root of a squared minus x squared dx is equal to this. So a squared over 2 times sine inverse of x over a plus x over 2 times square root of a squared minus x squared plus c. Now, this is a very useful formula which can be used in many results where you have to prove. So I want to make a next video. I'm going to use this to prove that area of an ellipse centered at 0, 0 is pi AB.